now that we have both of our enemies set up, you'll notice that the process to create both the moss giant and the spider were literally identical. And the reason for this was because we have individual scripts and we created their functionality. What we have here is two enemy AIs that are independently controlled by their unique scripts, and they have one common script that shares functionality. Now, why did we focus on individual functionality and creating them separately like this versus creating the code once and just using the shared class for the enemy base class that we created? The reason for that is so that you could experience how to transition to class inheritance. Now, when working with class inheritance and polymorphism, which we'll get into later, is it adds a layer of complexity. It requires an additional thought process. What is more simple to do? What is easier? Is it easier to develop with a mindset of, oh, I need to be able to reuse this and have modular approaches to everything? Or is it easier to, hey, let me focus on this individual functionality, and then at the end, we can optimize it by bringing together shared functionality? I needed to push you guys into getting ready for class inheritance because it's not an easy subject to get used to. And the best way to grasp those concepts is to literally just be thrown into it, which is why we added that layer of complexity that didn't make much sense in the beginning. However, I hope you've seen that with both of these enemies, they are identical. Their behaviors are identical. And what we want to use our abstract class for, or our base class, is we want to use it as a guideline to define our enemies, but also have shared implementations. Now, just because the spider and the moss giant have identical behavior, it doesn't mean that later on we can't add something unique and specific to the moss giant or the spider. And what we want to ensure is that we create flexible programs so that we can accommodate that in the future. So for example, what we're going to do is we are going to create and merge our data into our shared enemy class. However, if I wanted to add something unique to the spider or the moss giant, I'm going to make it so that I still can. So let's take a look at how to do this. If we look at our moss giant script and we look at our spider script, literally identical one for one. And that's because I wanted you guys to focus on just the concepts and just the programming on getting something to work. And then once you realize, hey, I'm writing this twice, and if I have 50 enemies, I don't need to write this 50 times, I can then look into ways to optimize this. So here we have our enemy, and we have things like a health variable that we share, a speed variable that we share, we have gems, we have our transform points, we have our protected transform point A and point B, and then here we have an attack method that we share. Just to make things simple, for now, let's remove the attack method. Let's not even focus on it. Once we've done that, let's save our script. Let's go into the moss giant. Make sure that he only has code relevant to him. Let's go into the spider and make sure we only have code relevant to the spider. Okay, so what we can do now is this class is going to be used as a guideline that implements enemies. So we have a giant and we have a spider that have all of these shared traits. Well, we can also share movement code, but we want to provide the ability for them to use the base implementation of the movement code, which is what we have, but if they want to add something custom and unique, they can. So to do this, we're going to create a virtual method here. It doesn't have to be abstract. Like for instance, if we wanted to force them to use a method like what we are with update, we use public abstract void update. But if we want them to have the ability to use shared code that runs along all enemies, like the movement code is shared, then we can use just a virtual method. So here we have public virtual void, and we're going to call this movement. Public virtual void movement. Every enemy AI, or every enemy that we create that inherits enemies, so like our spider and our moss giant, they will have a movement method that is optional for them to use, and it's going to have all of this code. So here we have public virtual void movement, and the way we're going to transition this over is we need to consider what variables are unique to each of these. Now, when we were creating this, we have variables that are unique to their sprites. Well, each enemy is set up the same. You can see here in the inspector that our enemy spider is a parent object and our moss giant is a parent object. And within that is a sprite. as long as we design our enemies consistently, there is no problem with us just having one animator variable and one sprite variable to hold the references to those objects. So what we can do here is we can actually hop into our enemy here, and we can create a variable that's going to keep track of the current target, and that can be private. We can say here, we can say private vector3, and we'll say current target. And then we can also take a look at our Moss Giant here, and we can see that we have an animator and we have a Moss sprite. So let's focus on the animator. Let's get a reference to our animator. So, and we also want to make this protected and not private, because if we do end up having a custom implementation, we can only access it from Moss Giant and Spider if it's protected. So we want to make sure that it is protected. So here we have protected vector3 current target. All right, and to keep everything consistent with our other protected member variables, we're going to remove the underscore. So here we have protected vector3 current target, and then we also have protected animator, and we'll call this anim. All right, this is the enemy's animator. And then here we're going to say protected sprite renderer, and we'll call this underscore sprite. This is the enemy sprite. What we can do now is we can actually create an init function. And this init function on void start, we're going to tell Moss Giant to, hey, call my init function, as well as the spider function, as the spider to say, hey, call my init function on the base class. So one of the things we'll do here is we'll say public virtual void, and we'll call it init. This is going to be an initializer function. Think of it as like your void start, for example. So here, public virtual void init, and what do we want to do when we initialize this? We want to initialize the animator component and the sprite component. So we're going to say anim equals get component in children, and we're going to grab the animator component. Now, why does this work? Well, this is an enemy, and the Moss Giant inherits enemy, which makes the Moss Giant an enemy. It's on the parent object, and I'm just simply grabbing the get component in children for the unique instance of this enemy, which is the Moss Giant or the spider or whichever enemy you're working on. We're going to do the exact same thing for the sprite. We're going to say sprite equals get component in children. So sprite equals get component in children, and we're going to say sprite renderer. And there we go. So here we have public virtual void init, anim, get component in children, and we have sprite equals get component in children. All right, so we will now save this. Let's see here, we have public virtual void init. All right, and let's continue on. So here, this is going to be our initialization function. Basically, this script could even function this for us. So on our, I'm going to show you how we can initialize default values in our enemy class, and then also if the Moss Giant has other things that it wants to initialize that are specific to it, we can do that as well. So continuing on here, we have our init function, which is going to grab the animator and sprite components. From there, let's grab our movement code. So here we're going to say we have our movement code, and let's just grab this. So we're going to control X. I'm going to bring it into my enemy class here for movement. And here we have public virtual void movement. And again, guys, the reason why it's virtual is so that in your child class, you can overwrite this method. You can rewrite the functionality of this code. So here we're going to say if current target equals point A. So current target needs to lose the underscore. So current target needs to lose the underscore. Make sure you remove that. And then what else needs to happen here? Well, we see here we have an issue with Moss Sprite. Just change that to underscore sprite. As you can see, we are drastically increasing the production quality of our code, because now we're writing all of this code once. We can have 50 AI objects that now share this class. Alrighty, everything looks good here. From there, let's go ahead and clean up our Moss Giant script. Let's get rid of this. We can not call the movement method. We can just get rid of this. And then last but not least, we want to make sure that we are checking if we are in the idle state. Then we need to block. All right, so we're going to go ahead and take this code, bring it into the idle. And I'm sorry, guys, just to keep consistent with the protected namespace, remove these underscores. Remove that. I'm just removing the underscores. Okay. Now that we have this set up here, what we can do now is we can go into our update method here in the enemy. And the reason why I made this abstract void was to demonstrate that you can force your enemies to implement a function. So we don't really want to force them to do this because we can actually do it just fine right here. And if we want to allow our enemies to override the update method, well, then we can use a virtual method. So the difference between using just public void update is that the enemy update is also going to run parallel to our child update. If you don't want that to happen, then you create an overrided update, and it will use your child update versus the parent update. So here we're going to say virtual void update. And we want to basically say, let's move this up. We're going to copy that and paste it here. And in void update, we want to add that Moss Giant code. So take this, go into our enemy here, and we're going to say if anim.getCurrentAnimatorStateInfo.isName is idle, then we're going to return. If we save this, hop back into our Moss Giant script, you'll now see that literally there is once again nothing inside of our Moss Giant class. It is shared between the enemy class, and same goes with our spider. We can literally delete everything because now it's a modular script that's sharing information. It's using the enemy base class as a guide. Now we have this public void or virtual init. In order for this to work, if we were to run this right now, there are actually going to be some errors, and I want to demonstrate this for you. That init method we created is going to be used to initialize things for the parent objects, as well as allow initializations locally on the child objects. You'll see here that when we run this, we're getting null reference exceptions related to our sprite and our animator component. That's because we're trying to get a component that isn't initialized yet because this init method was never called. So one of the things we can do here is let's go ahead and create a void start for initialization inside of our enemy class. And the reason why we can do this is because it's using mono behavior. And that's the reason you can still drag your Moss Giant script onto an object. And from here, we're going to call the init method. All right, just like this. Let's save this. All right, and I'll show you why we created this init method in just a moment after we test it. And now it's all good. You'll see here that there are no errors. Our Moss Giant is running into some issues, so we got to look at that. And then if we look into our spider, he's also not moving. I believe it's because I'm not calling our movement function, and that is exactly right. So what we want to do here is just call our movement method and our update method of the enemy class. Save this. Head back into Unity. Let's run this again. And you'll see here that now we have idle, and both of them, once they're done, they're going to start moving. All right, and let's go ahead and check out. We have on the scene view the spider, and in the game view is the Moss Giant. And there you go. One script, functionality shared, a base class. Now about that init function, because we're using void start to initialize things, what's happening now is init is saying, hey, you need to initialize these components. Well, what about the health, speed, gems, etc.? What if we wanted those to be initialized, say, for example, just here? What if I had something very specific to the Moss Giant? Like, let's say the Moss Giant had a height feature that it could change to. So what we would do here is we would say public int, let's say height, okay? And let's set it to 5. By doing that, what's going to happen here is if I go into the inspector, you'll see here that it's set to 5. So height. If we click on our Moss Giant, you'll see here that it added the property height, and it's not on anything else. If I go to the spider, it's not there. It's specific to the moss giant, and I initialized it here. Another way to initialize things, though, is to, what if I wanted to, when the game, when the game's starting, we wanted to set it to some saved information, or we want to set it to 5 and like a void start. I can have a public void start, but the problem with this is then I have duplicate code, because now my parent object is going to get called, as well as my parent object would be called, as well as my individual start function would be called. Because look, inside enemy, we have a start method, and now I'm just calling a start method here. It's redundant. So how do I initialize something? Well, that's where our virtual method called init comes into play. What I can do here is I can create a public override method, which is going to allow us to override virtual methods. And I can say public override, and we want to override init. And you'll see here that it's helping us our tooltip. And it's going to be public override void init. And what it's going to do is it's going to automatically call base.init. So what's going to happen here is that the enemy class is going to call void start, and void start is going to call init. And it's going to recognize that my child class is taking over control, meaning that my moss giant is not going to run this code here. The only way it's going to run this code here in the parent is if I type base.init. Base gives me access to the upper level class, and then I type .init. That's going to call the parent's initializations, which for most part you want to do. And then here I can say height, let's go ahead and say height equals 20. So I no longer use void start in my children, I use init. Let's save this. Let's watch it in the inspector. And that wraps up how to merge and how to properly use class inheritance. Let's run this and test it out. Sometimes class inheritance, and most times I'd say most times, class inheritance adds a layer of complexity. But when you realize an effective use case for it, it is one of the best parts of C# programming and object-oriented programming in general. You'll see here that when we initialized, my height is 20. So just to run that one more time, currently the height is set to 5. When we initialize things, the height is now set to 20. And there you go. All right, so I'm going to open that script up. I'm going to remove this. I'm going to keep the override in it. It is best practice to keep this in case you want to use anything else for initialization. So let's just add a comment, use for initialization. And we're just going to call the base class on it. So if we don't have anything custom that we're going to initialize, we just want to make sure that, hey, call the base. Same for the spider. We can say here, public override init, void init, and that's going to call the base. So in case we have anything specific to the spider or the moss giant that we want to initialize, we use this method for initialization. Alrighty guys, I'll see you in the next video.